Welcome to your personalized deep dive. So you sent in the fourth edition of Artificial Intelligence, a modern approach by Stuart Russell and Peter Norvig.
Oh, a classic.
And let me tell you, you've got great taste. This book is like the bedrock of AI, and
Yeah.
we're going to unearth its most fascinating gems just for you. Get ready for a journey that's both enlightening and, dare I say, a little bit mind-bending.
It really is. It's a real exploration of what it means to create intelligent machines and what impact they might have.
Right.
It really dives deep into the history, the concepts, even the philosophical implications.
Okay, so first things first, what even is artificial intelligence? You'd think there'd be a simple answer, right?
Right.
But it's surprisingly slippery.
It really is. It's one of those things that's easier to describe than to actually define.
Yeah.
But Russell and Norvig, they lay out four different ways to think about AI, each with its own focus. One is the acting humanly approach. Remember the Turing test?
Oh, yeah.
That's where a computer tries to fool a human into thinking it's another person.
Right, like a super advanced chatbot. But wouldn't that just be a really good trick? Is that all it takes to be considered intelligent?
It's more about the skills involved.
Yeah.
To pass the Turing test, a machine would need to understand language, reason, learn, and even have a sense of humor.
Hmm.
That's no easy feat.
So it's less about the trickery and more about achieving a level of capability that we associate with human intelligence.
Right.
What are some of the other approaches?
Another one is thinking humanly,
Okay.
which takes inspiration from cognitive science. It's about figuring out how we think and then trying to replicate those processes in machines. It's like reverse engineering the brain to unlock the secrets of intelligence.
That makes sense. If we want to create artificial intelligence, it helps to understand the original model.
Right.
What's next?
There's also thinking rationally, which is all about logic and reasoning. We're talking about creating rational agents,
Okay.
AI systems that make decisions based on sound principles and evidence, almost like a superpowered Sherlock Holmes.
Always choosing the most logical path. So not just mimicking human thought, but actually exceeding it in terms of pure rationality.
Exactly. And finally, there's acting rationally. This is about building AI that makes the best decisions, even if their process doesn't look exactly like how humans think.
Hmm.
The focus is on results, not just imitation.
So efficiency is key here.
Right.
So four schools of thought, each with a unique perspective on what AI really means. Before we dig deeper into each of those, let's take a whirlwind tour through the history of AI. Where does this whole journey even begin?
Well, the early seeds were planted way back in 1943
Wow.
when Warren McCulloch and Walter Pitts created a model of artificial neurons
Okay.
inspired by how our brains work.
Huh.
This was groundbreaking stuff.
Yeah.
They showed how networks of these artificial neurons could perform computations, essentially laying the groundwork for neural networks.
So they were essentially trying to create a digital brain neuron by neuron. That's incredibly ambitious for the 1940s.
It was. And then in 1949, Donald Hebb came up with Hebbian learning, which proposed that connections between neurons strengthen as they fire together. It was a major step towards understanding how machines could learn.
The classic neurons that fire together, wire together.
Yeah.
It's amazing how these early ideas still resonate in modern AI.
It really is.
What happened after that initial spark?
Well, the 1950s were a time of great enthusiasm and expectation.
Okay.
Researchers were showing that machines could tackle tasks once considered uniquely human. Arthur Samuel created a checkers program that learned to play better than its creator, demonstrating the potential of machine learning.
So right from the early days, we see this tension between mimicking human intelligence and surpassing it.
And
Did this early success continue?
There were definitely some heady days. The term artificial intelligence was officially coined in 1956 at the Dartmouth Summer Research Project, a gathering of some of the brightest minds in the field. They were tackling problems like language understanding and problem solving, using simplified virtual environments called microworlds.
It sounds like they were trying to give AI a playground to learn and grow in.
Exactly.
What were some of the key breakthroughs from this era?
One was the development of Lisp by John McCarthy, the programming language that became synonymous with AI research. There were also significant advances in game playing, like those early checkers programs, which were a real testament to the potential of machine learning.
It's fascinating to see how some of those early ideas, like machine learning, are still driving the AI revolution today. But I imagine it wasn't all smooth sailing, right? Did this initial wave of optimism last?
Not quite. While there were successes, researchers also ran into some roadblocks.
Okay.
The limitations of early AI systems started to become apparent. They could solve problems in simplified controlled environments, but struggled with the complexities of the real world.
So a bit of a reality check for the field.
Right.
Were there any specific reasons why this initial optimism faded?
One factor was the limited computing power available at the time. The algorithms needed to process vast amounts of data, simply couldn't keep up with the demands of complex AI tasks. Another challenge was the limitations of early neural networks, which weren't powerful enough to handle the complexity of real-world problems.
So a combination of hardware limitations and the need for more advanced algorithms led to a slowdown in progress.
Exactly.
What impact did this have on the field?
This period from the late 1960s to the early 1970s became known as the AI winter. Funding for AI research dried up, and the field experienced a period of disillusionment.
It sounds like a tough time for AI researchers. Did anything positive come out of this period of introspection?
Absolutely. The challenges of the AI winter forced researchers to reassess their approaches and to focus on more practical applications of AI. This led to the development of expert systems,
Okay.
which were designed to solve specific problems using knowledge gleaned from human experts.
So instead of aiming for general intelligence, they focused on more specialized, domain-specific AI.
It's exactly. One famous example is Dendril, a program developed at Stanford that could analyze mass spectrometry data to determine the structure of molecules, a task that was incredibly complex for humans to do manually.
So even during the AI winter, there were still significant advancements happening.
Oh, absolutely.
What other examples of expert systems were there?
Another groundbreaking system was MYCIN, which used a rule-based approach to diagnose blood infections. It could analyze patient data and suggest diagnoses and treatment options, often outperforming human doctors in its accuracy.
Wow, AI playing doctor, that's impressive.
Mm-hmm.
But even with these successes, were there still limitations to these expert systems?
There were. They were expensive and time-consuming to build,
Okay.
relying heavily on human experts to input their knowledge. They were also brittle,
Okay.
meaning they struggled to adapt to new situations or unexpected inputs.
So while expert systems showed great promise, they weren't quite ready to take over the world just yet.
Not quite.
What happened next in the evolution of AI?
Well, in the mid-1980s, there was a resurgence of interest in neural networks, thanks in part to the development of the backpropagation algorithm, which enabled the training of more complex, multi-layered networks.
Okay.
This paved the way for the deep learning revolution we're seeing today.
Ah, backpropagation. That's a name you hear a lot in modern AI. What made it so important?
It essentially provided a way to effectively train those multi-layered neural networks, allowing them to learn more complex patterns and solve more challenging problems. This was a turning point, but it wasn't without its challenges. The computing power needed for these more complex networks was still a limiting factor.
So even though the algorithm was there, the hardware wasn't quite ready to unleash its full potential. Did this lead to another AI winter?
There was a period of disillusionment in the late 80s and early 90s. The ambitious goals of the Japanese fifth-generation project, which aimed to create intelligent computers using massive parallelism and logic programming, didn't quite pan out.
So another dip in the roller coaster ride of AI development. But if I'm remembering my AI history correctly, this wasn't the end of the story.
You're absolutely right. The late 1990s and early 2000s saw the rise of intelligent agents, AI systems designed to act autonomously in complex environments.
So like virtual robots making decisions and taking actions on their own.
Exactly.
What spurred this new focus on intelligent agents?
This shift coincided with the explosion of the internet and the availability of vast amounts of data. This data proved crucial for training more sophisticated machine learning algorithms,
Okay.
which could now learn from real-world examples at a scale never before possible.
The big data era. It's amazing to think how the internet, something that wasn't even around in the early days of AI, became such a driving force for its progress. What impact did this data explosion have on AI research?
It was transformative. The combination of big data-improved algorithms and increasingly powerful computers led to breakthroughs in areas like machine translation, speech recognition, and image understanding. This was also the time when AI started to defeat human champions in complex games, like Deep Blue beating Garry Kasparov at chess in 1997.
Yes. I remember that match. It felt like a real turning point. Was this the moment when AI finally started to live up to some of that early hype?
It was definitely a pivotal moment. AI entered a new era of progress and practicality. It wasn't just about theoretical possibilities anymore, but about real-world applications that could have a tangible impact on people's lives.
Okay, so we've gone from the early days of artificial neurons and the excitement of the 1950s through the AI winters and the rise of expert systems to this new era of big data and intelligent agents. It's been quite a journey. Now, before we dive into the amazing things AI is doing today, I want to talk a bit about the authors of this book, Stuart Russell and Peter Norvig. What makes them such prominent figures in the world of AI?
Well, their work really embodies this shift towards intelligent agents and the power of probabilistic reasoning. Stuart Russell, a professor at UC Berkeley, is known for his focus on making AI both safe and beneficial for humanity. He's a strong advocate for responsible AI development.
So he's not just interested in making AI smarter, he's concerned about making it ethically sound as well.
Absolutely.
That's reassuring to hear. What about Peter Norvig?
Peter Norvig is a director of research at Google and is renowned for his work on search algorithms and AI applications. He's also a pioneer in making AI more accessible to everyone through projects like his online AI course, which has reached hundreds of thousands of students worldwide.
That's fantastic. They're not just brilliant researchers, but also incredible educators. Okay, I think we've laid a solid foundation here. We've explored the different ways to define AI, taken a whirlwind tour through its history, and learned a bit about the rock stars behind our source material.
Yeah, it's a rich and fascinating field, and we've only just scratched the surface.
I'm excited to dig deeper. Next, I want to hear about AI's triumphs in the modern world. Where should we start?
Let's begin with something we all interact with almost daily. Our smartphones. AI is embedded in so many of the apps and features we use every day, often, without us even realizing it.
That's a great place to start. I'm ready to dive into the world of AI-powered apps. Let's go.
Welcome back to our deep dive into artificial intelligence, a modern approach.
I'm ready to pick up where we left off. Last time we traced the evolution of AI from its early days through those AI winters to the explosion of data and the rise of intelligent agents. It's amazing to see how far we've come.
And how far we still have to go. As AI becomes more powerful and more integrated into our lives, we have to consider the ethical implications.
Right.
That's something Russell and Norvig emphasize throughout the book.
Right. It's not enough to just build AI that's smart. It has to be good too. But how do we even define good when it comes to artificial intelligence?
That's the crux of it. We can't just expect AI to understand human values and ethics intuitively. It needs guidance. And that leads to some fascinating questions about how we align AI systems with our goals and values.
So it's like teaching a machine right from wrong, but on a much grander scale.
Exactly.
What are some of the ways we can do that?
Well, one approach is to give AI systems explicit ethical guidelines, almost like a rule book for artificial intelligence. Think of it as Asimov's laws of robotics, but for the real world.
Right. A robot may not injure a human being. Those are good starting points, but aren't real-world ethical dilemmas a lot messier than that?
Absolutely. A set of hard and fast rules can't cover every situation. That's why we need to explore more nuanced approaches, like using machine learning to train AI systems on ethical behavior.
So instead of programming specific rules, we could feed AI systems examples of ethical and unethical actions and let them learn to distinguish between the two.
That's one possibility, but it comes with its own challenges. We have to be incredibly careful about the data sets we use for training. If those data sets are biased, we risk creating AI that perpetuates those biases, and that could have serious consequences.
That's a really good point.
Yeah.
We don't want to create AI that inherits our worst qualities.
Yeah.
So data quality is crucial. But are there any other safeguards we should be thinking about?
Another idea that Russell and Norvig bring up is the concept of humility in AI.
Humility.
They argue that we should design AI systems that acknowledge their own limitations and are willing to defer to human judgment in uncertain situations.
So instead of blindly following its programming, the AI would know when to say, hey, I'm not sure about this one. Maybe a human should take a look. I like that. Keeps humans in the loop.
Exactly. We want AI that complements human intelligence, not replaces it. That also means being able to understand how AI systems make decisions. We can't treat them as black boxes.
Transparency is so important, especially as AI starts making decisions that have a real impact on our lives. Speaking of impact, I wanted to ask about AI and jobs. There's a lot of fear about robots taking over the workforce. How do Russell and Norvig address that concern?
They acknowledge that AI and automation will inevitably change the job market. Some jobs will be lost, but others will be created. It's like any technological revolution. There's disruption, but also opportunity.
So it's not necessarily a zero-sum game. We don't have to choose between humans and machines.
Exactly. The key is adaptation. We need to focus on education and training programs that equip people with the skills they'll need to thrive in a future shaped by AI.
So instead of fearing AI, we should focus on preparing for it. What kind of skills do you think will be most valuable in this AI-powered future?
Well, it's not just about technical skills, although those are certainly important.
Right.
We also need to cultivate skills like critical thinking, creativity, and emotional intelligence, the things that make us uniquely human.
Those are the skills that AI can't replicate. Yet, anyway. So it's about embracing our human strengths, the things that set us apart from machines.
Absolutely. We're good at collaboration, empathy, and understanding the nuances of complex situations. Those skills will be in high demand even as AI takes on more routine tasks.
That's reassuring. It's not about humans versus machines. It's about finding ways to work together, each playing to our strengths. Now, I wanted to touch on another topic that Russell and Norvig emphasize: governance and regulation. How do we make sure AI is developed and used responsibly?
It's a crucial aspect. We need clear guidelines and ethical frameworks to steer the development of AI in a direction that benefits all of humanity. It's like establishing traffic laws for the AI highway. We need rules of the road to ensure safety and prevent chaos.
Love that analogy. So who's responsible for creating these AI traffic laws?
It's a collaborative effort. We need governments, industry leaders, researchers, and the public to work together to define those ethical frameworks and create regulations that foster innovation while protecting human rights and values.
It sounds like a complex task balancing progress with safety. Are there any promising developments in this area?
There are. Organizations like the Partnership on AI, which brings together major tech companies, are working on establishing best practices and ethical guidelines. Governments around the world are also starting to grapple with the regulatory challenges of AI. It's a work in progress, but it's encouraging to see this level of engagement.
It's definitely reassuring to know that these conversations are happening. We need to make sure we're steering AI in a direction that benefits everyone, not just a select few. So we've covered ethical guidelines, workforce adaptation, governance, and regulation. It's clear that AI isn't just a technological revolution, it's a societal one.
It's about much more than just building cool gadgets. It's about shaping the future of humanity.
Well said. I'm ready for the final part of our deep dive. Let's hear what Russell and Norvig have to say about the future of AI and what it all means for us.
Join us in part 3, where we'll explore the philosophical questions raised by this book and consider what the future might hold for humanity in the age of intelligent machines.
All right, we're back for the final part of our deep dive into artificial intelligence, a modern approach. I'm ready to hear what Russell and Norvig have to say about the future of AI. What's in store for humanity as these intelligent machines become more powerful and more integrated into our lives?
Well, this is where things get really interesting, even philosophical.
Okay.
The book tackles some big questions about consciousness, the nature of intelligence, and what it means to be human in a world increasingly shaped by AI.
I'm all ears. Give me those mind-blowing concepts. What are some of the most thought-provoking ideas they explore?
One that really grabbed my attention is the idea of superintelligence.
Just short kind of.
AI systems that surpass human intelligence in every way imaginable.
Okay.
Could we even comprehend how such systems think or what motivates them?
It's a mind-boggling concept. It's almost like trying to imagine the thoughts of a being from a higher dimension. Do Russell and Norvig believe superintelligence is inevitable, or is it more of a hypothetical possibility?
They don't give a definitive answer, but they do urge us to seriously consider the implications of creating something that might fundamentally outthink us.
Yeah.
Could we control it? Would it even want to be controlled?
Right.
These are questions that go beyond technology and delve into the very nature of power and existence.
It's both exciting and a little unnerving, like we're standing at the edge of a vast, uncharted territory. It's clear that we need to proceed cautiously and thoughtfully. What other big questions do they grapple with?
Another fascinating concept they delve into is consciousness. Could machines ever truly become conscious, experiencing the world in a way similar to humans? Could they have subjective feelings, a sense of self?
Those are some deep philosophical waters. If a machine can solve problems and learn, does it also need to feel to be considered truly intelligent? What's the book's take on that?
Well, it's a question that's been debated for centuries, and Russell and Norvig don't pretend to have all the answers. But they do encourage us to think critically about how we define intelligence and consciousness, especially as we create machines that increasingly blur the lines between human and artificial.
It makes you wonder what the future holds for humanity as we venture further into this uncharted territory. Will we coexist with these super intelligent, potentially conscious machines? Or will they become our successors?
That's where the idea of human-compatible AI comes into play.
Okay.
It's about designing AI systems that are fundamentally aligned with human values and goals, systems that enhance our capabilities and contribute to our well-being.
Human-compatible AI. I like the sound of that. It's a more hopeful vision of the future one, where humans and AI work together to build a better world. How do Russell and Norvig propose we achieve that kind of harmonious future?
Well, they stress the importance of open dialogue collaboration and responsible regulation. We need to have those tough conversations about the ethical implications of AI, and we need to work together across disciplines to steer its development in a direction that benefits all of humanity.
It's a reminder that the future of AI is not preordained. It's shaped by the choices we make today, the values we embed in these powerful systems.
Exactly. Artificial intelligence. A modern approach is more than just a textbook. It's a call to action, an invitation to participate in shaping the future of AI. It encourages us to ask those difficult questions, to consider the potential consequences of our actions, and to work together to create a future where AI serves humanity, not the other way around.
Well, this deep dive has certainly given me a lot to ponder. It's been fascinating to explore the history of AI, the challenges and possibilities it presents, and the profound questions it raises about the future of humanity.
It's been a pleasure to share this journey with you.
And to you, dear listener, I hope this deep dive has sparked your curiosity and given you new insights into the incredible world of artificial intelligence. Keep asking those big questions, keep exploring, and keep learning. The future of AI is in our hands. See you on the next deep dive.